All right, let's do some imports. So I guess most of you didn't move, so you're now modeling gurus of the graph thanks to a bit of Robinson training. So now, next obvious step, let's import some data. All right. So at Neo, we're constantly kind of looking around, trying to find like data sets that look like they might be fun to put in a graph. And one that Ian pointed to me about a year ago is this one here. So this is Chicago crime, because obviously we don't want to pick London crime, because then we'll all feel unsafe. So Chicago crime it is. So the US government has got this website called DataGov, and you can go there and they give you this Chicago crime data set, and you get a CSV file with all the data in. So you zoom in to that right-hand side, and you kind of get this thing, and it goes, hey, what do you want to export it? And given there's really easy tooling in Neo4j for importing CSVs, we'll do the CSV option. And so the goal, obviously, with any import project is to get to the dollars. I don't know if we'll get to the dollars in the talk. Maybe you can find the dollars. I can do the first two bits. So what we want to do is we want to take this file at a very simplistic level, take this file and get it into Neo4j, and then query, and then dollars, and then happy days. Okay, so the first step we want to do, as with pretty much any data problem that you take, is we want to explore it and have a look. What have we actually got? Now, I suppose typically what you would use before you came here today is you'd get out ACK, maybe a bit of SED if you were Ben, a bit of grep. But actually, there is a cooler way. You can actually explore this stuff using Neo. So we're going to have a look at that to start with. So this is an example of a query here, which allows us to have a look at the CSV file and not actually import it at all, but just have a look at what is actually there. So we'll go through it. So basically the command, this is very, very similar to what Emil and Ian have shown in their previous slides. It's just another clause or another keyword. So we're saying I want to load CSV. By the way, there's some headers, so we give it a bit of a hint. I want you to get it from this location. So this is where it is on my laptop. I want you to refer, and we're basically going to iterate over every row in the CSV. We're going to call it row. We could call it anything, but we'll go with row. And then we're going to return one of them, and we'll limit it to one. But step one, let's start the Neo4j up. So I'm one version behind Emil. He's gone a bit hardcore and gone right on the milestone in the talk. So it might look a little bit different, but I think it'll be all right. Okay, so we get to here. So I guess you've seen something similar to this, and we can run that query. And there we go. So we get like so if I scroll it a bit, you can kind of see what is actually in this in every row. So there's obviously a very uniform structure. And the reason this is quite a fun one to work with is it's almost identical to a Hadoop dump that I got given on one of the clients we were working on. They're like, here, make a graph. Right? Okay. And then you've got to do this. You've got to do this step. It's also the same as if you took your relational database and joined every single table together and go, hey, there you go. There's one record. By the way, there's also 7 other ones hidden in there, and you've got to figure out what they are. And so if you kind of, if I scroll a little bit, you might be able to see a few standing out that you might think, oh, those ones seem like they might be entities that I want to extract and make a graph. So I'll show you the ones that I came up with and we can see whether they're the same. So we've got, as you've seen, we've got this overview. This is one row. Effectively, the row is now showing as key value pairs instead of as a record. And these are the ones that I thought were the most obvious ones that you could pull out if you were wanting to do some graph-based queries. These are the fields that stand out as being potentially useful ones. So we've got I grabbed the year. So there's also a date further up, but I thought we'll start with the year. We've got the primary type of crime. This is a really fun column to read. It's like, what crimes can you actually commit? Gone for assault on this one. Obviously, the other nice thing about using an American data set is the type of crime is just way above what you can do here. Because once you've got a gun, it's like suddenly your options are really huge. So we've got locations. This is quite sad. It's like assault in the apartment. It's really bad times, this data set. And then we've got the beat. So this is the police beat that it happened on. So I guess you could then narrow in and say, that guy is clearly not patrolling his beat very well. There's a lot of assault going on there. Okay, well, maybe you might not do that query if you didn't want to get beaten up by the police, I suppose. All right. So here's my 2 years of training from Ian has led me to a model. And this is roughly what I thought might be interesting to start with. So we've got the crime. So every record is representing one crime. So just out of interest, I think there are 6 million rows over 15 years. So it's quite a lot of crime. I don't know, Nicole can probably work out in her head how many that is per day. I imagine it's quite a bit. And so what we've said, so imagine we were trying to make a graph out of that tabular data. So we could say, so we've got the crimes, that's our main thing. And perhaps it's committed in a location, so that was like the apartment or the street or whatever other location it is. And we pulled out a node for the crime type, we've got another one for the year, and then we've got another one for the beat. Okay, so that's fine. So that generally is the first step. You don't need to get this doesn't need to be perfect, it just needs to be something. And then you can start, and then as Ian pointed out, you can iterate on that and come up with something that's more suitable for the queries that you want to run. But for now, let's go with this. So now, rather than just using load CSV to explore the data, what about if we import some data? And I've generally found working on these types of projects, the easiest way to go down the massive yak-shaving path is to attempt to do all the data in one go, and then eventually something goes wrong, you're like, oh, I've got to start again. So I tend to like take a little bit of it and import that and have a look. Does that seem to work? Can I actually write the queries that I want to write? And then add more data in. So we can do a little bit of that. So I've chosen 100. It's reasonably easy to see 100 rows. If we copy this in into the browser, so I'll just go through it. Look at those beautiful red lines that PowerPoint puts in. So same thing. So you recognize this line. So this is exactly the same as before. So we're saying load CSV. So hey, here's my file. I want you to process it. We've done an extra line here. So this is a way of kind of passing through intermediate parts of the query. So we're basically saying, I only want to pass through 100 rows, so I don't want to any more than 100. And I want you to create me a record for the crime, or a node for the crime, if it doesn't already exist. So the reason I've done it like this is because I tend to make mistakes doing this, and I run the scripts over and over again, and it's just easier if the database saves me from having to do the uniqueness. So merge is match or create. So we're saying merge, create me a node. We don't actually necessarily need this name. We could delete this. I'm saying I want a label for crime so that I can easily go and find it later. And then I'm going to put some properties on. So these are properties that are in the CSV file. So there's a header in the CSV file, and we're just taking each column, and then we're importing it. So we do that. So now we've got 100 nodes, and we can have a look over here. We can see, cool, we've got some crimes. But that's all we got, so it's not particularly interesting yet. So let's go back and let's have a look. What could we do? What could we do next? We've got the crimes, that's the main thing. Now we want to try and find something that we're going to connect it to. So first thing is there's a column called primary type. So that's the type of crime, obviously pretty ghastly, but we could choose to import those. So we'll do this step and the next one together. So it's exactly the same as before. All we're doing is we're processing a different column from the file. So everything else is the same, and then different properties and different label. Other than that, structure's the same. And then once we've done that, we're going to connect these two bits together. So we kind of got all the crimes, we've got all the crime types, and then we're going, let's connect them together. So we've got something interesting to query. And what we can do here, so this script assumes the other two have run. So that's just in case you're wondering why we're using a match. So what we're saying here again, process my file. I want you to match any crimes that I've put in. We're going to use the ID in the description to do that. And then I want you to match the crime type. So we're going to get two nodes. And then on the final line, we're going to connect them with a type relationship. And then we'll have a graph of around 100 crimes and crime types and the connections between them. All right, so let's have a look at that. If we minimize that. We'll load that in, go to the next one, load that in too. And what we can do now is refresh, I should have picked it up. We can have a look at the types. So we see we've got it's quite a reasonably simple graph compared to the ones Emma was showing you before. But we've got criminal damage, what have we got? Robbery, assault, and those are all connected to the crimes. And so if we wanted to go we could now go and do a reasonably simple count. We could say, let's grab the we do, I call it crime type. We could do crime type, and we could do, we could have a look how many of each crime have been committed in our very, very small sample. Let's have a look. Okay, so we can go here. So battery out of the, so not good, Chicago for that. Bit of theft, bit of narcotics, burglary, motor theft, and sort of bit of deceptive practice. This is my favourite one. I really like deceptive practice as a crime. I'm reporting some deceptive practice, officer. I can't imagine what the police person would say if you reported that. Okay. Okay, so that's just a few rows. If you're actually going to use this on a bigger data set and probably load CSV, you can get up to about a million, maybe a little bit more if you're a bit more patient, and then you probably want to move on to something else, which we'll talk about as well. But one thing you definitely want to do is you want to put indexes on the properties of those nodes that you're creating. So I haven't done that yet. So what we probably do, so this is the syntax. We say create index on, and then the name of the label. So we had crime and crime type, and then the property, whatever it is. So we had, I think we had ID, and then we had name. And then, so this is what it would look like across the whole model that we designed a few slides ago. So we'd say, I want to create an index on crime, ID, location, name, crime type, and so on. And so when you run that command, it will index any future nodes that you create, and it will also go back and do the existing ones as well, which is quite nice. And basically, all the time while you're building this, what I find myself doing is building yourself a little script. So maybe I'll make this a little bit bigger so you can see at the back. Is it big enough, Nicole? Okay. So I'd be building, and this one's got 10,000 in, so I'd be building my indexes up here. I'd probably build the crimes in there. I'd build some crime types. I've got a few other ones as well. They all follow the same pattern. So in true programming style, copy paste all the things and slightly tweak. That's the main approach that was used here. So you can kind of see we've got all the different things here. One thing I haven't explained, using periodic commit. So we'll do that now. So I go back to here. So using periodic commit is it's kind of a language feature that's tied to load CSV generally because people attempt to load these massive CSV files like me, and Neo4j keeps its transaction state in memory. So you can imagine if you attempt to load every single row into memory and create a node for every single one, the amount of memory is probably bigger than what you have. So what periodic commit allows you to do is actually flush it on a certain interval, certain number of rows. So the default is 1,000. So that makes this much easier to do. So we say every 1,000 rows, flush whatever you've done off the crimes. Yeah, that's about it. Yeah, so you can change the number if you want. It's only tied to load CSV, so don't go and try and using periodic commit all the other things because it will be a syntax error, and then you'll be sad and you'll go to the mailing list and you'll be like, should have looked at the slide. Okay. So I'm going to run this in a sec, but just to quickly summarize, what would you use this for? So effectively, it's really, really good at the beginning. So I've got some data and I don't know what it is. You can explore it really nicely with this. It's been in Neo4j since 2.1, so it might be about a year. So it's been there for about a year. You can load. So I was loading from files, but you can also load from URLs if you want to give it a HTTP URL or whatever. You can point it at that, and it will import that for you as well. We've seen people get it reasonably working for up to 10 million rows. I don't quite have the patience for 10 million rows, but if you are more patient than me, then you could probably try that out. And just to wrap this section up, so as I showed you this script we'd kind of built up, and so the way that I would typically build it is when I'm working out whether the model works and whether the model works, I do it in the browser. Once I'm happy with what I've got, I'm probably going to move over to use the shell instead. So this is a command line tool that you get, and you can basically, where's it gone? Bin, Neo4j shell. And then I'm going to point it at that script, so it's sample. And then we can watch it. Oh, not quite. What have I done wrong? So you need to actually tell it it's a file. And then it'll go through and it runs each query one at a time. Okay? And it won't take so long to do this amount of data. All right, how are we doing? So we nearly got. So this is taking effectively the first 10,000 of each of the things if it can actually create, if it actually matches the ones that happen further down. Okay, so this probably, I don't know how long that took. 4, 8, 14. So it's about 30 seconds. That's about my attention span. So not so good. Bit slow. So obviously that was only for 10,000. So if you want to do the whole data set, I find that it's much easier to use a new tool that we put into Neo4j 2.2. which is an offline. So you can like build this data set offline, and I don't actually want to connect it to anything, so it's absolutely, it's good with me to build it offline. And so it's called the Neo4j import tool, and it sits under the bin folder, so where your Neo4j is, your Neo4j import tool will be. And this is really good for doing large initial data sets. And again, it works with CSV files. It skips the whole, completely skips the transactional layer. It's basically building the store files directly. If it crashes, you have to start again. So this is kind of the caveat of using this tool, but it's very, very fast. Right, now the other constraint that we have is that we need to give it files in a certain format. So it expects files in this format here. So this is for our data set. So you have to give it files representing nodes, and you tell it what is going to be your ID column. So like before where we did our merge and we said ID, you've got to tell it, hey, this is the ID column that I want you to use. So we're going to say, I'm going to put my ID in this one, and I want it to be a crime. So this is called an ID space. So you basically need to say, across all the CSV files you're going to give me, I want you to treat the ones with crime as being unique. So you can't repeat an ID within an ID space. If I put, in my crimes one, I put IDs of 1 and then 2, and it will blow up and say, hey, by the way, you've already got a 1. So these need to be unique. And then we've got the same for the beats, and then to connect them together, you need to make use of the ID. So you need start ID, end ID, and then the type of the relationship. And you can, as you can see, you can put properties anywhere along. So you can put properties here, you can put properties along here as well. Now that's a bit annoying because we don't actually have the file in that format. We've got it in this format that the US government helpfully gave us. So we need to figure out how we're going to translate this the data into the format that Neo4j's tool requires. So we're going to have to do some translation step. And I thought it would be quite fun to play around with Spark. And this seems to be the hottest thing to hack around with. So what I've done, I'll show you next, is we've got Chicago crime file. We want to get it. We're going to create a Spark job to take that CSV file and spit out lots of new ones that Neo4j loves, and then we're going to import it into Neo4j. So there's a couple of steps. So this is roughly what the Spark job looks like. So Spark is a kind of engine. You pass it a job, it goes off, and I'm basically massively abusing Spark for the purpose of this talk in running it only on my laptop. The intention is you run it across a cluster and it calculates stuff really, really fast. Instead, I'm just calculating stuff really, really fast because I'm really lazy and couldn't be bothered to write a program that would do it for me, and Spark had a nice abstraction. So you basically get a job, and you can kind of see on the top line, I tell it, by the way, there's going to be a CSV file. You can get it from this environment variable. Tell me where it is. Create a Spark context. So that's just its kind of initialization step, I suppose. Then I get rid of the header, so I didn't want the header. So that's literally all that method does. And then this is the main bit that you need to read. So we're generating some files. So we're generating a primary types file, we're generating a beats file. There's some other ones. There's a crimes file, there's a locations file, and then we're telling it which columns should it take from the original one. So we're saying, I want you to take column 5 there. I want you to take column 10 here. And then there's some other ones further down as well. And then this is what the file looks like. So we're basically just running a CSV parser over it. And if you pass in distinct, we'll make sure all your rows are distinct. The rest is kind of just gluing it all together so that we end up with one file. This is how you would call it. So we're going to have a look at how to do this for the last few minutes. So basically, you download Spark. You can call Spark submit. You pass it a job. So my class is called generate CSV file. So I say, hey, can you use that? Run it locally. And by the way, here's the jar with everything in. And I'll run this, and then while we're running it, so I've made it into a file called create files. So you can have a look. I'll have a look at that one. So this is create files. It's basically the same as what we had. So while that's running, so it'll take about a minute. I'll show you what we're going to do with it. Okay. So once we're done, we're going to get some files, and we're basically going to do this, and we're going to see a whole load of files. So we'll have a quick look at them in a sec. So we're going to get those files, and there's going to be some for nodes, some for relationships, and then we're going to import it into Neo. And this is what the syntax of the Neo4j import tool looks like. So I've just defined some directories at the top. So I'm saying get the data from temp. That's where I put it. Neo we're going to use 221, and then we're going to run the import tool. So this is the command. You say into, so where do you want to create it? So I'm just putting it in a random folder on the machine, and then you say I've got some nodes here, more nodes here, and so on, and then these are the relationships, and then run it. Okay, let's see how is the job getting on in the background. Still going. Takes about a minute. Man, I did all that talking in less than a minute. I knew I talked fast. All right, we're done. Okay, so let's have a quick look, final thing. So if we look in here, so if I clear that, so that's 11:46, yeah, so it's just now. So we've got all our files. Let's have a quick look. What have we actually got in them? So the crimes one's probably the best. As you can kind of see here, this is basically what we designed on the other slides. We've got an ID crime, we've got a label, which is crime as well. We've got date, description, case number, so we've put in some other things as well. And then our final step is to run the import thing. So say import, temp, and then Neo4j221. And so now we're doing the import bit into Neo4j. So the Spark bit took about, I think I got it on the slide how long it takes. But it's probably about a minute. Yeah, a minute 25. So let's see how long the Neo4j bit takes. So it kind of goes through, it has some very clever code behind the scenes that works out what the optimal way of processing this is. So it does the nodes, then it goes the relationships, kind of builds the chain one way, goes back, builds it the other way. Also, you can kind of see here, it shows you when it's handling dense nodes as well. So those are ones which have more than 50 relationships coming in or out. And we're done, 34 seconds, and we've got it. And it basically sits in this folder. So that's our database. So we're done. So if we look at the times, 11:48. Yeah, 11:48. So that's cool. And then if we want to get that running, because I probably don't have time to show you how to get it running, but effectively all I did was I just switched this flag here and point it at that database instead, and then it would be all the data loaded, and it probably took about 2 minutes altogether. Right. So to wrap up, obviously this talk was sponsored by Chicago Tourism Board, and yeah, that's the end. So thanks.